Hello, my name is Aruna Chauhan and today I'm going to discuss energy diagram of E1 and E2 reaction. So let's start. So E1 reaction, what is the full form of E1 reaction? E1 is unimolecular elimination reaction, and what is E2? E2 is bimolecular elimination reaction. So first we are going to learn about the E1 reaction energy profile diagram. So here I have taken progress of reaction on x-axis and means on this axis, and on this axis I'm going to take energy. Okay, so here you see two peaks. There are two peaks. So these peaks are representing here transition state first and transition state. This is for the transition state second. Okay, so what happened in this reaction? You know that in first step, because E1 is the two-step process. Okay, so in first step, what is going to happen? In first step, formation of carbocation intermediate is going to take place in E1 reaction. So what is going here? Here, this is the reactant, and this reactant is going to convert in first process into the intermediate. So this is our intermediate. You can say they were carbocation intermediate. Okay, so before this intermediate, what happens? This carbon and halogen bond is going to be weak, means we can say it is a leaving group. Okay, so we can just consider it as a leaving group. So this is leaving group is going to be removed from this carbon atom. Okay, so because there is the difference in the electronegativity between carbon and halogen. So here you see that this leaving group is going to be detached from this carbon. Okay, so how this is happening, how this bond is going to be weakened? Okay, so this is the solvent here, which is polar protic solvent. You know about the polar protic solvent, I hope. So the polar protic solvent have some kind of dielectric constant. So due to this dielectric constant, these polar protic solvent is just going to weaken the force of attraction between this carbon and this leaving group. So what is going to happen? They are just helping this leaving group to get removed from this carbon, or you can say this from this substrate. So in transition state first, what is happening? This bond is becoming weaker. Okay, now in this step, in the first step, what is formed? This carbocation is formed in this first step, which is known as the intermediate. Okay, so next what is going to happen? In the next step, you know that charge species are not that much so stable, so they want to means get convert into the product. So what these charge species are going to do? Here on this carbon, hydrogen is present. So suppose some weaker base is just coming towards this carbon just to attract the hydrogen of this carbon. Okay, so this base is going to attract or is going to pull out this hydrogen from this carbon, because it is a base. So what bases do? Bases are just looking for the donation of their electron to the electron deficient atom or site. Okay, so what these bases do? The base just going to attract or just going to detach this hydrogen from this carbon. Okay, so this hydrogen is going to donate its electron pair, or you can say donate its electron to this carbon, or to this carbon means between this carbon bond. So what is going to happen? There is a formation of pi bond between this carbon and this carbon. You can see here there is the formation of a pi bond between this carbon and this carbon. So we can say that this is two-step process. In first step, formation of carbocation is happening, and in the second step, what is happening? The formation of the product. Okay, so we are forming a product from the substrate, and substrate is here saturated. Okay, so we are forming unsaturated product from a saturated substrate. okay, or you can say reactant, okay. And this is the energy profile diagram for the even reaction. You know, this reaction is endothermic reaction, okay. So it take place at higher temperature, okay. I hope this diagram is clear, okay. So let's move towards the second diagram, which is for the E2 reaction. So here we see there is only one peak present, okay. In E2 reaction only one peak is there. This is the reactant. In this, what is happening? So what happened in this? The reactant is going to convert into the product through this single step process. There is no formation of carbocation intermediate here. Here only the formation of transition state take place, okay. And this transition state is known as concerted single step process, or this the formation of this transition state is also known as the concerted single step process. Why it is known as the concerted single step process? Because in only one step, what is happening here, one atom is going to leave the site, okay, and the another atom is also going to leave the site, and the formation of pi bond is going to happen in this process. Means all these process, the formation of the bond and the breaking of the bond is happening only in a step, only in a single step. So that's why it is called concerted single step process. Okay, so you can see here, this is the leaving group and this is the hydrogen. This hydrogen is going to be attracted by this strong base. Okay, this strong base is going to attract this hydrogen, and this leaving group is going to leave the site from here, and there is the formation of this pi bond. So in E2 also, the formation of unsaturated product from saturated product is going to happen. So you can observe it here, okay. And you can also observe one more point here, that this halogen and this hydrogen, these both are anti-periplanar, means these both are opposite to each other. So in E2 reaction, what happened, the leaving group and the hydrogen should be anti-periplanar to each other, or you can say that should be anti to each other or opposite to each other, okay. So E2 reaction is also endothermic process. In this reaction also heat required. Okay. So I hope the energy diagram of E1 and E2 reaction is clear to you all. Okay. Thanks for watching.